Good morning, committee and audience. My name is Natwadee Attakan, the fifth year medical student from Faculty of Medicine, Prince of Songkla University. Today, I would like to present my research project on the topic of prenatal diagnosis of beta-thalassemia and hemoglobin E using multiplex milk curve with high-resolution melting analysis in southern Thailand. Let's start with the introduction. My beta-thalassemia and hemoglobin E are the common genetic disorder in Thailand and Southeast Asia. Prenatal diagnosis is essential to determine the genetic status of the fetus among couples at risk for severe disease. Molecular techniques such as reverse dot hybridization and gap PCR are commonly used to detect the mutation. And however, this method requires further post-PCR step, time-consuming and high cost. So our study aims to develop milk curve with HRM assay and to assess its efficiency in prenatal diagnosis of beta-thalassemia and hemoglobin E in certain population. For the method, leftover fetal DNA sample extract from the amniotic fluid were collected, and monoplex HRM assay were developed for genotyping of hemoglobin E and 11 beta-thal point mutations, and 3 multiplex HRM assay were developed for 6 deletional mutations, including 2 beta-thal mutation and novel method for detecting for hemoglobin F determinants. And in the process, 2 to 5 DNA sample which no genotype were used in the optimization, and then the optimized HRM assay were validated in 182 fetal DNA blood sample. And the HRM results were compared with the RDB, gap PCR, and Sanger DNA sequencing result. And lastly, we evaluate the lower limit of detection. And for the result, figure 1A shows a specific milk curve pattern among different mutations, and figure 2B shows the specific TM for 6 additional mutations in multiplex HRM. And table 1 shows HRM analysis result of 41 genotypes. This technique demonstrates 100% concordance with conventional methods. And figure 4 shows the relationship between DNA concentration and amplification of PCR cycle to determine the lower limit of detection. And additionally, the developed method could screen for unknown point mutation in the promoter of the beta-globin gene. Further confirmation using single DNA sequencing show a beta nucleotide minus 88 mutation. And we comparing the efficiency of our HRM to conventional method. The HRM assay has lower cost, less time consuming, and does not require further post-PCR steps. And for the discussion and conclusion, our developed HRM technique can identify various beta-tau mutations, a total of 18 mutations, which cover 95% of beta-tau cases in certain Thai population. And we found for the first time beta nucleotide minus 88 mutation, which has not been reported in Thailand. This mutation was found in India. And HRM assay is an efficient method and can be used routinely for prenatal diagnosis of beta-thalassemia and hemoglobin E. And lastly, I would like to thank you, my advisor, and everyone who contribute to this research. This work is supported by research funding from Faculty of Medicine, Prince of Songkla University. Thank you for your attention.
Such an impressive work. Are there any questions or comments?
May I ask you about the criteria of selection of the sample? Do you have any criteria for selection?
Yes.
Yep.
Yes, the inclusion criteria is leftover DNA sample extract from amniotic fluid from the routine test with the point mutation and last deletion in a beta globin gene. And we use a leftover DNA without mutation in the beta-globin gene. Yes. And exclusion criteria is DNA that not part the qualify of DNA sample. Before we collect the DNA sample for this research, we qualify by the nanodrop and agarose gel electrophoresis. Nanodrop by the we exclude the DNA that has a protein contaminate or the salt contaminate. Yes, and the agarose gel we qualify about the we exclude the DNA smear that degradation of DNA.
May I ask a question from online? Yes. I saw your abstracts about the samples that you used the 183, but when you present in the poster it's 182. What I am puzzling is about the false negative ones that you found. If as you presented in the abstract, could it be what was wrong there, and could it be 100% concordance as you presented?
Yes. Okay. The result in the abstract is the result that we from the HRM assay, and then we exclude one sample. One sample was excluded due to the insufficient DNA to confirm the Sanger DNA sequencing. Because the result not different from the conventional, and then we must confirm with conventional, confirm with the Sanger DNA sequencing. But because the insufficient DNA, and we can confirm by the Sanger DNA, so we must be exclude this sample. Yeah.
That was 183 minus 182, and you still have another one that missing.
Is another one the HRM assay when confirmed to conventional, when confirmed with the Sanger DNA sequencing, HRM show the result same the DNA sequencing, but different the RDB. The true result is DNA sequencing, and HRM same show the result same the Sanger DNA sequencing.
So, in your opinion, is it going to be a new standards for screening beta-thal E?
HRM not screening, but it is diagnosis.
Yes, I mean that. Sorry. Yeah, going to be a new standard tools for diagnosis, right?
Yes.